All right, welcome to Unit 1, Lesson 6. This is the third and final video for this lesson. Let's get started. We left off doing either the M method or slip and slide, and now we have a couple more examples. If you aren't sure what those are, go back and watch Unit 1, Lesson 6, the second video. All right, so I'm going to start off by doing the M method. Right here, I know I got 6w squared. I have a positive 4. And if I multiply 6w squared and 4, I should get 24w squared. So this brings us to a situation where what multiplies to 24w squared but adds to 11w. And my answer for that is minus 3w minus 8w. Okay, so negative 3 times negative 8 is definitely 24. And negative 3 plus negative 8 is definitely negative 11. So it passes, it works for us. So we use minus 3 and minus 8. Now, we go back to factor by grouping. Okay, I'm going to group these two together and get our greatest common factor. And I'm going to group my second two terms and get out a greatest common factor. So if I do this right, I can pull out a 3w. And what would be left? 2w minus 1. Now for my parentheses in the red here, I don't just want to pull out a 4 because that would give me negative 2w plus 1. That is not the same as this. Okay, the signs are different. So if I want to flip the signs, instead of taking out a 4, I'll take out a negative 4, and that will flip both of my signs, and it will match. So I'm going to take out a negative 4 and get 2w minus 1. And that's really the key to doing any factor by grouping. I want this parenthesis to match this parenthesis. So my last step is I take my 3w minus 4, put that in one parenthesis. Then I take my 2w minus 1 and put that into another parenthesis. Now, I could have done slip and slide, and I would have gotten the same answer. So let's take a look at this second one, okay? I can do slip and slide or the M method and still get the answer. Since I did the M method for this first one, I will do slip and slide for this next one. Slip the 2 out back, and I've got x squared minus 7x plus 12. Now I'm going to factor this like I would any other quadratic. Multiply to 12 adds negative 7. So it's x minus 4. And it's x minus 3. So I'm going to check that. Minus 4 times minus 3. That's a positive 12. All right. Minus 4 plus a negative 3. Negative 7. Good. So now, slip the 2 out, multiply. I've got to slide the 2 back in after I factor. And I divide. Okay, the opposite of slip is slide. The opposite of multiplying is dividing. And I reduce if I can. Okay, this fraction right here turns into x minus 2. I cannot reduce 3 over 2. I cannot reduce this. So now I do bottoms up. My bottom comes up. 2x minus 3. Done. Again, I could have used the M method, but I use slip and slide. I personally like slip and slide better, but this M method isn't bad either. Not at all. All right, factoring perfect square trinomials. So if you have a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, this is kind of all confusing. I will explain what all that means momentarily. So if you look at example 1 here, this first one, I would completely expect you to say what multiplies to positive 9 and adds to negative 6. X minus 3, x minus 3, because minus 3 times minus 3 is 9, and minus 3 plus minus 3 is minus, I'm saying minus, but it's negative, negative 6. So that works. All right, that's what this should factor out to be. All right, and some people just write it, x minus 3 squared, because I'm multiplying it by itself. And that's correct. Okay? But what this method is telling me here is if I have perfect squares, just like the dots, the difference of perfect squares. All right, but this one has a middle term. All right? Remember when we did things earlier and we took the square root of the front and the square root of the back, and one was a plus and one was a minus? That was either on the second or the first video when we did that. This is also perfect squares. And what do I mean by perfect squares? All right, I'm going to keep this here because this is what our answer should be. The square root of x squared is x. The square root of 9 is 3. Whatever sign is in the middle, in our case the minus, goes there. And we're done. That's it. Now, how do I know this works out? How do I know that x minus 3 times x minus 3 is going to give me, my minus 6 in the middle? All right? This right here. If I take my first term, x, and multiply it times my last term, okay, which is negative 3, and I double it, it should equal my middle term. Negative 3 times 2 is negative 6. Here's my x. Negative 6x. Negative 6x. That's just a quick check. If that doesn't work, then I cannot do this method. Okay? So, every time we do this, we're going to use this check right here. Let's take a look at the second example below here. All right, I know x squared is a perfect square, and 25, y squared is a perfect square, so let's check this. The square root of x squared is x. The square root of 25, y squared, is 5y. Plus, right in the middle, boom, squared. I need to make sure that works, so I take my x, I multiply it times my 5y, and I double it. I multiply it times 2. 5 times 2 is 10, x, y. Is that the middle term? It sure is. Works like a charm every time. So this check right here, that's taking your 2 and multiplying it times whatever your terms are when you take the square root, your a and your b. Okay? That's what that means. Do you have to memorize that notation? Not really, no. But I'm just trying to explain to you what it means. All right? Let's do the next one. Let's go purple. All right? Look at this. I know 64 is a perfect square. That's 8x. 1 is a perfect square. 1 times 1 is 1. There's a minus sign in the middle here. So I'm just going to put it here. Boom. Done. So let's make sure that's right. I'm going to take my first term, 8x, multiply it times my second term, negative 1, and I'm going to double that. All right. Negative 1 times 2 is negative 2. Negative 2 times 8 is negative 16x. Like a charm. I love it. So, Visca, how do I know this is a process I should be doing? The very first thing you should recognize is the first term and the last term should be perfect squares. All right. We have some, I'm going to move this up a little bit. We have some problems here, and they want us to factor them completely. So now we might be using not one method, but multiple methods to factor this. And it gives us a hint. If we can take out a greatest common factor first, we should. All right? So if you want to pause this, try these three on your own, go ahead. I'm about to do them right now. All right, this first one. I know there's a common factor between 2 and 8. That's 2. 2 goes into both of them. I also see that they each have a y. So I'm going to factor out a 2 and a y. Now, please remember that when I factor out, that's like dividing. So my 2 cancels, my y cancels, and I have x squared. My y's cancel, minus 8 divided by 2 is 4. All right, that is not factored completely. It's factored, but not completely. How come? Because this can be factored one more time. I have 2 perfect squares. The square root of x squared is x. The square root of 4 is 2. But notice, there's no middle term. Like the previous problems, they had a middle term. This one does not. This is a difference of 2 perfect squares, it dots. In order for that middle term to go bye-bye, I need a plus, and I need a minus, because the plus and the minus cancel out the middle term. And I still can't forget my 2y. That comes along for the ride. That is factored completely. Let's take a look at the next one right here. All right, I see a 2 goes into both everything. There's a 3, a 6. 3 doesn't go into 28 or 10. So I can take a 2 out of all these terms and an x. All right, and what does that leave me with? 3x squared minus 14x minus 5. All right, well, I can't factor out a greatest common factor anymore. All right, 3 and 5 are not perfect squares. So this is going to be either factored by m or slip and slide. These are one of those hard trinomials. So I'm going to do slip and slide. Now, please keep in mind, I'm going to slip and slide just what's in parentheses here. My 2x is going to come along for the ride. My 2x still needs to be in my answer. But for right now, I'm just focusing on what's inside the green parentheses. Slip the 3 out back. So that x squared minus 14x minus 15. I'm going to factor this. All right, x's, what multiplies a negative 15, but adds to negative 14, negative 15, and positive 1. All right, so flip the 3 out, I factor. I need to slide the 3 back in with division. So x minus, this reduces to 5. I can't reduce 1/3 anymore, so bottoms up. 3x plus 1. I am not done, because I cannot forget, in my answer, I still need my 2x out here. And I am done. So I've done more than one factoring task to solve both of these problems. This first one, greatest common factor, then dots, a difference of perfect squares. The second one, okay, greatest common factor, yep, I'll be okay. Greatest common factor, then slip and slide for the rest. Let's do the third one right now. All right, again, purple's nice. Well, there isn't a number I can factor out here, but they all have an x. Greatest common factor. I'm going to take one x out of everything. So I have two x's left here, plus 4, and I have one x left in the middle, minus 12, and there are no x's left when I take out my x. Now, oh, this isn't too bad. X. I'm going to do my product sum, meaning two things that multiply to negative 12 that add to 4. Why am I going to try that? Because this is a 1x squared. I always love to have 1x squared there because I can go right to this. Okay? So what two numbers multiply to be negative 12 that add to positive 4? Well, 6 times 2 is 12. Okay, and if I'm multiplying, to a negative number, I need to multiply a positive times a negative to get a negative 12. So what two numbers can I multiply that are different by 4? 6 and 2. But which one's the plus and which one's the minus? Remember, the bigger number always takes that middle sign. The 6 is bigger than the 2. There you go. Nice. These last two problems, I really don't like them. They're not all that common. This is just trying to help you see how things are structured. Okay, seeing structure. Here's what I'm going to do. We have these two sets of x squareds here. Okay, and it kind of throws me off. Wouldn't it be nice? Let's use another letter. Let's use v. If I had v squared minus 3v minus 10, I could factor that. Let's go ahead and factor that. Two numbers that multiply to negative 10 that add to negative 3. Okay, so I'm going to put a v here, and I'm going to put a v here. So let me see. I know if I need to multiply to get a negative number, I need to multiply a positive times a negative. So different signs. What are two numbers that multiply to be 10 that are different by 3? 5 times 2 is 10. They are different by 3. Okay, so which number is which sign? The biggest number is the sign in the middle. My 5 should be negative, and my 2 should be positive. All right, good. But it still doesn't help us with this x squared. Initially, I told you it would be better instead of x squared if we had a v. So what we did is we quite literally said, let's make x squared equal to v. We substituted our v's in here. Okay, so now this is factored, but we didn't start with these. We started with x squared, so what is v equal to? V is the same thing as x squared. So I'm just going to substitute my x squared back in. Every place I have a v, I'm going to put my x squared back in. How come? Because every place I had an x squared, I made into a v. So it made my life easier. Now I get to the end, and I got to put my x squared back in for my v. All right? Let's try the next one. I think you guys are starting to get this. Let's try this last one right here. Ooh, this is even worse. I have 4x plus 1 squared plus 4 times 4x plus 1 minus 12. All right, let's use, first of all, purple. Love it. Let's use f. Anytime I see 4x plus 1, I'm just going to make that an f squared plus 4 times f minus 12. So what I'm doing is I'm going to say, instead of 4x plus 1, I'm going to make that an f. I'm setting that equal. I'm substituting that in. Let's factor this. Two numbers that multiply to be negative 12 that add to positive 4. And of course, I'm using f's here. Okay, in order to get a negative product, I need to multiply a positive times a negative. If my signs are different, what are two numbers that multiply to be 12 that are different by 4? 6 and 2 multiply to be 12. 6 and 2 are different by 4. Okay? So, which number gets which sign? My bigger number, the sign in the middle. So my 6 is positive, my 2 is negative, but I can't give my answer with X in it. Whatever I took out to put the F in, okay? So initially, I took 4x plus 1 out to put my F in. So now it's time to take the F back out and put my 4x plus 1 back in, plus 6. 4x plus 1 minus 2. So if I wanted to clean this up, I can. I have 4x, 1 and 6 would give me a positive 7. 4x, 1 minus 2 is negative 1. There you go. That's the answer. Enjoy life, because now math is easy.